You may recall from the first chapter that all of matter can be divided into two categories: pure substances and mixtures. Pure substances can either be elements or compounds. We've spent a fair amount of time this semester with elements and compounds. How to write them, how to write the formulas, how to name them, how to calculate things about them like masses and moles, how to put them in chemical reactions. But the reality is as we are in lab in chemistry, a lot of the things that we use are actually mixtures instead of pure substances. And mixtures come in two varieties: homogeneous or heterogeneous. What we're going to focus in on in this chapter is homogeneous mixtures. Homogeneous mixtures are mixtures that have a uniform composition throughout, but they are indeed mixtures and not compounds because their composition can vary. In a compound, you have a chemical formula. The chemical formula is set. It doesn't change. For example, water is H2O. There are always 2 hydrogen atoms for every 1 oxygen atom. There's a specific mass ratio of hydrogen and oxygen in this formula. Sodium chloride is NaCl. There's always 1:1. Sodium to chlorine, we can look at the mass ratio, and every single sample of salt stays the same. In a mixture, in a homogeneous mixture, there is more than one compound and the composition can vary. For example, I can have a mixture of salt water. Salt and water together make a homogeneous mixture. If I stir it up and all the salt dissolves, there is the same amount of salt at the top of the container as there is at the bottom of the container. But I can make varying compositions of salt water. They can be very concentrated or very dilute, and these are words that you're familiar with. Other examples of homogeneous mixtures that we're familiar with: Kool-Aid, coffee. All of these have varying compositions in that different people can make them different ways. You might like your coffee straight black, you might like your coffee with sugar and cream, and even if you like your coffee with sugar and cream, you might put a different amount of sugar and cream in your coffee than someone else. We still call those coffees, but they're mixtures because they have varying compositions. So we're going to focus in on the varying composition of mixtures. Alright, when a mixture is made, let's think of our salt water. Essentially what you're doing is you are dissolving the salt in the water. We say that we're dissolving it because it goes into the solution, and the thing that you're dissolving in the solution is usually referred to as the solute. Another way to think of the solute is it's the substance that you have the least amount of. The substance that you have the most of, what you are dissolving into, is a way to think about it, is called the solvent. And another way to think of it is the solvent is what you have the most of. And together, these make up a solution. I like to abbreviate solution SOLN. So we have our solution, which is made up of a solute and a solvent. When the solute dissolves in the solvent, it literally disperses throughout the solvent uniformly. Eventually, it might take it a minute to get there. We call this process solvation. If it happens when water is the solvent, we can call it hydration. If you have a solution where water is the solvent, then we refer to that as an aqueous solution. So let's talk about our aqueous solution of salt water. Salt, the NaCl, is the solute, the water is the solvent, therefore we can call it an aqueous solution. We all know that you can make this aqueous solution just by taking a cup or a beaker. There's my cup. Put some water in it, and then just spoon in the salt. And as you spoon the salt in, you stir it up and the salt dissolves. You probably have come across the fact that if I keep adding and adding and adding more and more salt, at some point I will notice that it appears that the salt stops dissolving and falls to the bottom of the container. So I would have a little pile of white crystals on the bottom of this beaker at the bottom of the water because I've added so much salt that it's stopped dissolving. When this happens, we say that we have saturated the solution. or we can say that the solution is saturated. We have added as much sodium chloride as this solution would hold. Now, sodium chloride is able to dissolve in water. If something is able to dissolve in water, we say that that is soluble. S-O-L-U-B-L-E. Watch your spelling. It's also really fun to say, soluble. You should try saying it. So sodium chloride is soluble in water, but at some point, if I add so much, it starts falling to the bottom. We say that the solution is saturated. If I keep adding more and more and more, it is still saturated. Above the point where it starts falling, the solution is saturated. Now, before the point that it started falling to the bottom, while it was all still dissolving, we say that that solution is unsaturated. So an unsaturated solution has the ability to dissolve more solute than you have already added. But then if you keep adding more and more and more, then you usually get to the point where the solution is saturated. There is also a third condition for a solution. It's a special case. It's called supersaturated. In a supersaturated solution, you have somehow tricked the solution to dissolving more than what would saturate it. So for example, if I kept spooning in, and it got saturated, then I would somehow manipulate the solution to make all of that solid go into solution. I would manipulate it so that all of it would dissolve, even though it's at room temperature, for example, it's falling to the bottom. For example, I might heat it, and at the higher temperature, more of the solid might dissolve. And then if I slowly cooled it down back to room temperature, I could trick the solution under certain circumstances into keeping all of that solid dissolved. And so literally I have more solid dissolved than the saturated solution would say I could. And that's called supersaturated. But you have to actually try to supersaturate a solution. Now with this concept of a solution being unsaturated, meaning I have not added as much as I can so that it's falling to the ground, to the bottom of the container yet, if a solution is unsaturated, there can be varying amounts of solute and solvent. And this goes back to what we were saying earlier, in that a solution's composition can vary. And so we need a way to indicate how much solute and solvent there is in my solution, and this is with the idea of concentration. Again, this is a word that I'm sure you're familiar with. The concentration of a solution is a way to quantify, to put a number on the solute and solvent. Usually it's a ratio of some sort that your solution contains. There's a numerical value, and it can vary depending on the composition of your solution. For example, one concentration unit that you might be familiar with is a percentage. It's very similar to our percent composition when we were looking at chemical formulas. This works essentially the same way. The percentage of solute is the mass of the solute over the entire mass of the solution times 100%. You may be familiar with solutions that come as a certain percentage, and percentages are a way to express concentration. You might also be familiar with the fact that depending on the concentration of the solution, you might refer to the solution as being concentrated, and you might refer to the solution as being dilute. A dilute solution would have less solute per solvent. A concentrated solution would have more solute per solvent. These are relative terms. They're relative terms, meaning that you're referencing them against something. So a dilute solution is not a specific numerical value, it's just relative to a concentrated solution.